So what was the pattern? If it was sine nx, I meant nx, the number of roots, that is f of n, was n plus 1, except for a few cases. So let's think about the exceptions a little later, and let's think of these cases first. So if I want to add all the number of roots going from 2 to 2007, that's nothing more than adding all the numbers 2007 and adding 1 plus 1, because the number of roots was always one more, not always. Most of the time it was one more than the n. You saw that, right? Okay, but not always. When was it an exception? When it was a 5, 9. In other words, when it was a multiple of 4 plus 1, it was a problem. So, because you saw it. It coincides exactly on top when this number is one more than multiple of 4. So if I get 5 here, you will see that's the problem time. It should have cut twice, but they match exactly, so it loses one root. Instead of 6, you get 5. And multiple of 4 plus 1, here it happens. So multiple of 4 plus 1 at 13 is going to happen again. You see? And should I go on? At 17 it's going to happen again. Okay, now you're curious, how far can it go? It could go pretty far. I programmed until 32 only, so it's like that. But it's perfectly capable of just filling in the whole thing. And besides, you're supposed to go to 2007. Pretty far, eh? Okay, so every 4, 5, 9, and all those things would not be considered. I mean, these are the exceptions that would eat away. So I got to take away however many of these guys I have. So I started 5, 9, and as you saw, I got 13, and then I would have 17. But where would it end here? I got to end at 2007, but where is the multiple of 4 plus 1? So if I have 2007 divided by 4, I get 5, 20, 0, and I get 7 here. So I fit only 1, 4, 3. Okay, so it has 501 multiples of 4 in it. And the last multiples of 4 would be whatever I multiply. It's 2004. That's the last multiple of 4. If I do one more, it's 2005. So it goes up to 2005. Okay, and which is within the reach of 2007. So that's how many it's going to be. But how many are these? 5, 9, 13, and all. Then how do you compute how many numbers are in a list like that? Well, you may know right away, but if you want to cheat, you do this. You know, it goes up by, a sub n, all that. You could do that, but let me show you how to just quickly figure out. You can look and see there are 4 numbers, right? You know it's going up by 4. How can you get 4? I mean, how many numbers there are by looking at this? You do 17 minus 5 over 4. What does that give you? It is 12 over 4 is 3. I have 4 numbers. It gives me 3. So it is one more. So how many numbers are all in here? You do? Okay. 2005 minus 5 over 4. So you get 2000 over 4, which gives you, what is it? 500. Then you say, oh, 501. The reason I'm putting 501 is because it is, each time this multiple happens, the number that you should have been was always one less, right? Do you remember? If I am supposed to get, for example, let's see, 13 here. If I was supposed to get 14 answers, I got 13 answers because of this. So I was one less. But in the next one, when I go 14 here, the answers were, I'm sorry, here. You cannot see very well. Let me go down here. At 5, it was disappointment. I'm supposed to get 6, but I got only 5. 1, 2, 3, 4, 5. But if I go to 6 here, it recovers. It gives me back 7. See, 1, 2, 3, 4, 5, 6, 7. So it's not like the numbers got pushed down. Only in those you just get raw deal of getting one less number. Only for that. It doesn't have any repercussion for the next ones. So Each time you lost one in like that, and how many times did you have that kind of loss? 501 times. That's how you got that. Okay, now let's compute all this, shall we? You know how to add an arithmetic sequence, right? So arithmetic series is pretty easy. When you have something like this, okay, it is the first number, which is 3, right? When I plug in 2, I get 3. Plus the last number. When I plug in the last one, I get 2008. And times the total of numbers. How many would it be? You subtract and add 1. If you're not sure, to do this. 2, 3, 4. How many numbers are here? Obviously it's 3. How do you get that? 4 minus 2 gives you 2. It is one more than that. So 2007 minus 2 is 2005. It's one more than that. It's 2006. Divided by 2. This is nothing but the summation formula of arithmetic sequence. You should know this. If not, look it up. Arithmetic series. That's what you look up. Minus 501 is what we get. Okay. Time to do some arithmetic, but it should not be that hard. I do cancellation is 1003. What else do I have? When I add this, I get 6. No, I'm adding. I thought I was multiplying. If I add it, I get 2011 times 1003 minus 50. Oh boy. Okay. 501. Ooh, almost here. Okay, now if you want to be lazy here, you see when I multiply this, it would end in 3. 3 minus 1 would end in 2. So I look for end in 2. So I think it's got to be this one. That's the only one that ends in 2. So that's cheap way of getting away with these things, but that works. That happens to be the right answer. But if you want to do this, then you can go ahead and do it. This multiplication is not that bad actually. So 2011 and 1003, right? Shall we? So it's a 6033, and this would become 2011. So if I add this, I get what you see. So 201733 minus 501 would be 2016,532. Here it is. But, peeking into the last digit was more fun.